Are you looking for an effortless way to design secure systems that connect to the cloud service? Microchip offers the SAM-IoT WG Development Board as part of our smart, connected, and secure world to simplify your IoT design. Out of the box, the SAM-IoT board connects to the Google Cloud in just about 30 seconds. Using the power of MPLAB Harmony Configurator and the MPLAB Tools ecosystem, you can now add connectivity to the Google Cloud for your new and existing projects with just a few clicks. Let's look at the resources available on the board before we get started. On the core function part of the board, there are three main components. The ATECC608A is a crypto-authentication device, which provides secure authentication to the Google Cloud. The SAMD21G18A is an ARM Cortex M0 Plus microcontroller, which provides interaction with IoT sensors and other modules on the board. And the ATWINC1510 module provides connectivity via Wi-Fi. There is also a light sensor and Microchip's temperature sensor populated on the board to provide sensor data. On the support function part of the board, we have a power regulator, a battery charger, a USB connector, and a Nano eDBG programmer and debugger, shortly called NeDBG. Nano eDBG supports many features, including drag and drop, which is an easy-to-program feature without any tool. It also supports debugging and serial port features. There are 4 LED indicators on the board with different colors. Each LED indicates the corresponding status of the board. The blue LED indicates a successful connection to the local Wi-Fi network. The green LED indicates a successful connection to the Google Cloud. The yellow LED blinks, indicating a successful transfer of sensor data to the cloud. And the red LED indicates there is an error. Therefore, if the setup is successful, you will see that the blue and green LED are both on, and the yellow LED is blinking. To get started with the SAM-IoT board, we need to complete 2 simple steps. First, we need to set up the board with the Wi-Fi credentials of your local network. Then we'll need to see the sensor data publishing on the cloud. When the board is connected to your computer through a USB, you can modify or select the Wi-Fi credentials using a one-click option or using the command line through the serial port. You can use either a computer or your smartphone to see the sensor data published on the cloud. Let's walk through the options one by one. The simplest way to connect to the board is through the one-click or drag-and-drop option. After connecting the board to the computer through a USB, the board should be recognized as a flash drive. To set up the Wi-Fi credentials or to download the latest firmware, click on the Click Me file in the drive, and an HTML page will be brought up. On that page, you will see a web button to download the latest firmware. Click on the Get the latest firmware button to download the latest firmware. The drag and drop feature is a great way to program the firmware or the Wi-Fi configuration file to the board without using MPLAB X or any other tool. Extract and navigate to the hex folder in the downloaded zip file. Simply drag or drop the hex file to the flash drive, or in other words, to the board. The device then gets programmed with the latest firmware. On the same HTML page, scroll down to enter the Wi-Fi credentials of your Wi-Fi network. Enter your wireless network name. For this video, we will use MCHP. Select the network type as WPA or WPA2. Enter your wireless network password. Then, click on the Download Configuration button and a configuration file is generated. Simply drag and drop the configuration file to the flash drive, or again, in other words, the board. Within a few seconds, you should see the light and temperature sensor data published on the web page. You should also see that the blue and green LED are on, and the yellow LED is blinking on the board, indicating a successful connection and transfer of data to the cloud. Each board has a pre-programmed unique ECC serial number. With that serial number, you can access the sensor data in the cloud. Another way to set up the Wi-Fi credentials is through the command line interface or CLI through the serial port. In this video, we are using the serial terminal app TerraTerm. First, set up the serial communication by selecting the virtual COM port of the SAM-IoT board. Set the baud rate to 9600. And enable carriage plus line feed for the receiver and transmitter. Type help to display the CLI commands. Enter device to see the device serial number. This is the same pre-programmed unique ECC serial number which we saw on the web page earlier. Enter key to get the pre-programmed ECC public key. Type your Wi-Fi credentials in the following format: Wi-Fi space, your SSID, comma, your password, comma, authentication type, and then hit enter. You can refer to this Wi-Fi command format here. Then, within a few seconds, you should see the light and temperature sensor data published on the web page. As you can see, out of the box, the SAM-IoT WG Development Board provides an effortless way to design secure systems, connecting to the cloud in just a matter of seconds. We hope you have enjoyed this demonstration. We have provided some useful collateral links available for this board, and these are also available in the description below. Thanks for watching.